Okay, 4.3 practice A. Tell whether the angles or sides are corresponding angles, corresponding sides, or neither. So this kind of goes back to the last section. Angle N and angle P. If we look at those two, this one has 2 arcs, this has 3, so that would be neither. Angle M and angle P, that would be corresponding angles. LM and RP. So OM is between the 1 arc and the 3 arcs, and RP is between the 1 arc and the 3 arcs. So those would be corresponding sides. NO and QP. NO is the 1 arc and the 2 arcs. QP is 2 arcs and 3 arcs. So that would be neither. Decide whether the congruent statement is true and explain your reasoning. Well, the first thing I notice is these 2 triangles are touching and JH is in both of them. So now IJ, which is the first and the third, is congruent to JK, which is the first and the third. JH IH is the first and second, and JH is the first and second. But this has 2 marks and this has 3. So that would be false. Now for this one, IJH and KJH, those will be congruent. Remember, they have to be in the same order. So IH, we were then saying, is congruent to JH. And those are not congruent. This has 2 marks. It's congruent to HK. Number 6. Once again, they share this side, LP, so you could say that it's reflexive. LP is reflexive to itself. So then LP is congruent to PL. Those 2 are congruent. PS, which is the bottom one, is congruent to LN, which is the top one. And LS, which is this one, is congruent to PN, or NP, which is that one. So that would be true, and it would be side, side, side. Number 7, triangle ACE. So from A to C is 1 little tick mark. From B to D is 2 ticks. So that is automatically false. Number 8, S, T, V. Now that's congruent to itself. So S to T is the same as U to T. They both only have 1 mark. Sorry, shade that a little bit there. They both only have 1 mark. TV is congruent to TV, and SV is congruent to UV. They both have 2 ticks. So that would be side, side, side. Next figure, decide whether the figure is stable. This one has the diagonal running to it. So that would be a yes. This one does not have a diagonal running through it. So we're going to say no. Remember, congruent triangles make it stable. Use the given coordinates to determine if triangle ABC is congruent to triangle DEF. So basically we have to find the distance between A and B and A and C, and then B and C, and then find the distance between DE, DF, and EF. So, going from A to B, it goes over 1 and up 1. So AB, and here's how we do it. AB is equal to the square root of 2, because it's up 1 over 1. So it's going to be 1 squared plus 1 squared, and it's the square root of that, which is square root of 2, because 1 squared is 1, and 1 squared is 1. So let's try DE first. It goes up 1 and down 1. But if we put that in to our formula, it goes up 1, so that's 1 squared, plus negative 1 squared. So the 1 squared is 1, negative 1 squared is also 1, so that's the square root of 2. So DE equals the square root of 2. Those are the same. Now let's try BC and EF. So we're going to need those two to come in exactly the same. For BC, it goes down 1 and left 1. So 1 squared plus negative 1 squared. 1 squared is 1, negative 1 squared is 1, so it's going to be 1 plus 1, so it's the square root of 2. EF goes down 1 and left 1, so it's going to be negative 1 squared plus negative 1 squared, which is going to be square root of 2. So far, so good for number 11. Last one, you have to check AC. It goes over 0 and down 2. So that's going to give you AC equals square root of 2. It's going to be 0 squared. Oh, wait. Because it goes down 2, it's going to be 0 squared plus 2 squared, or negative 2 squared. Negative 2 squared is 4, 0 squared is 0, square root of 4 is 2. Let's try DF. DF goes over 0 and down 2. So DF is also going to be 2. Since AB and DE are the same, BC and EF are the same, and AC and DF are the same, this would be, yes, true. We have to go through the same procedure for number 12. Okay, goes up 3 and down 1. So it's going to be the square root of 3 squared plus negative 1 squared. Gives me 9 plus negative 1 squared is 1, so it's the square root of 10. So AB equals the square root of 10. DE goes over 3 and down 1, so it's literally the same exact thing. So DE equals the square root of 10. Now let's check BC and EF. BC goes left 1 and up 3. This will be -1 squared plus 3 squared. Hey, look, gives us the same thing, square root of 10. Let's try for EF. It goes left 2. This will be -2 squared plus up 3. So it's 3 squared. -2 squared is 4. 3 squared is 9. So it's the square root of 13. Already we see that that's not true. And so we can stop and say no. You don't have to do the third one. Number 13. Determine whether triangle ABC is congruent to triangle DEF. Explain your reason. Okay, so AB and DE are the same. EF and BC are the same. They're both 6. These ones are both 4. Now, from A to F is a distance of 2, and from C to D is a distance of 2. But see, this last little segment in here makes up the rest of both of those triangles. So up to here is 2, and then the rest of the way makes this. And then if you look at our markings, they're exactly the same way, going the opposite direction. And so that would be yes or true. You could say reflexive property. Okay, let's look at 14. FD, so that would be the first and third. AC, those are both 10. AB, DE are both 6. Then from F to B is 3. From E to C is 2. So those are not the same. That would be no. Two different gate doors are shown below. Which door frame is stable? I think based off of what you know so far, these are the ones with the congruent triangles. And so it's going to be the second one. Because of congruent triangles. This should be easy questions that you should never miss. Okay, that's the end of worksheet A. Tomorrow we'll do worksheet B tonight, and tomorrow I'll go over it.